Hang on. So yeah, I changed the name of this talk from Superscript to Talking to Machines. It's a little bit broader to kind of give a little bit more breadth to the problem space. I just wanted to say thanks again for such great talks. This has been an amazing experience to listen to some of these. And I also want to say thanks to Kenneth Ormanity, a colleague of mine, for proposing this talk for you guys and then helping me get over my public speaking. So it worked out well. So who am I? Just really quickly, I'm an open source hacker, and I primarily write software in the mobile, in the mobile space, and then the cloud space, and then more like front end stuff. Some friends and I created PhoneGap back in 2007, and then in 2008 we worked on XUI, which was kind of replaced by Zepto. So this was like when writing mobile JavaScript was sucked on the client, and it was a small little library, and it worked out really well. And then after that, I joined Joyent and worked on and around Node really early on, and that was a lot of fun. And then more recently in the front end space, so doing some pre-compiling, and I feel like the web is still got so much more to offer, and especially front end development, and then being able to write essentially all static. I think it's a really cool space. And then more recently, deploying and taking those assets and putting them online really easy. So I'm also behind some of that stuff as well. But I'm not here to talk about any of that. It's actually outside of my 9 to 5. So essentially the B track, the side projects. Somewhere along the line around 2010, 2011, I became interested in language. I found it was a really fun, fuzzy problem. And I started writing some tools for dealing with processing and tokenizing and stemming and classifying language. And that worked out to be a library called NL Tools, which then got merged in with Chris Umble's work called Natural Node. So we joined everything together and created an organization called Natural Node. And there's a lot of development still going on in that space. And then more recently, I'm kind of taking this all the way up the stack. I created a project called Superscript, which I'm kind of here to talk a little bit about. But first, I should say Superscript is a bot engine, so it's designed for writing human-like chatbots. And you can do a lot of other cool things with it, and I'll kind of walk through some of that. But first, let's look at the problem and kind of the history, in a couple of the other components that are involved in making talking to machines a reality. So what I'm really referring to here is text-to-speech, some sort of logic or AI in the middle, and then speech to text, then text to speech on the way out. On the speech to text side, Bell Labs kind of first entered the space around 1932. It was way too early. They came back and started working on it again in the 1950s and 1960s. And they were able to get the vocabulary model up to about 10 words. So it wasn't that great, but they were able to start the process. In the 1970s, DARPA picked up some of the work, and they added hidden Markov models to increase the vocabulary to around 1,000 words. And then the 1980s is when things got really interesting. That's when IBM joined in and was able to move the vocabulary up to about 20,000 words. And at that point, with the advent of hardware becoming a little bit more common and the prices of the compute coming down, it's gone even further since then, obviously. On the other side, text-to-speech really is known as speech synthesis. And essentially that involves text analysis and then some sort of linguistics analysis and then waveform generation. Those are the three kind of key pieces. The waveform generation, or the actual what comes out of it, it's really only made possible by how the text is interpreted. You get the tones and inflections through the linguistics analysis. This space is really old. So we saw the same kind of things kind of kicked off in the 1950s, when the computers, it was first electronic models were produced. But it's actually dating back to the 17th century. So there's a Danish scientist that was able to create a synthetic vocal cord and reproduce the first 5 vowel sounds. But apparently there's even legends going back to 1000 AD of something called the Brazen Head, which is like a bronze or brass statue apparently owned by these medieval scholars. And they were rumored to believe to be wizards. But more recently, we see text-to-speech has become popular. Partly Stephen Hawking was probably one of the first people we think of that made that kind of common. In the 1980s, again, is in the late 70s, early 80s is when things got really interesting. We see Texas Instrument coming in and working in the space, Mattel, Software Automated Mouth, or SAM, in 1982. And then later on, 1995 or so is when Microsoft kind of came on board. I should point out that the Software Automated Mouth was in the first non-Macintosh Apple computer, so the Apple II and the Lisa. And then the Texas Instruments' first commercialized product, the Speak and Spell. Has anyone ever seen or played with one of these? Kind of dating myself maybe, but my cousins had one. It was a lot of fun to play with. So this is kind of where we see, the first commercial product of it. But what about complete AI systems in pop culture? So there's, a fair bit going on, or we tend to draw from pop culture to kind of pave the way forward. And I'm not talking about all of it, but some of the stuff that influenced me a little bit. Going back to 1982, Knight Rider. I don't know if anyone's seen or watched this. So the 82 to 86. And this featured David Hasselhoff, which is pretty cool. He was ahead of his time as well. And the computer, essentially, the car was completely autonomous. I think it was also remote control, if I remember. And it had a funny little personality where, essentially, the computer a kit would, help Michael out. And then, of course, Star Trek. So, it seemed like every scene or every episode, there's some sort of interaction with the computer. And in this case, it's, the computer didn't actually say anything. It just kind of chirped. But the other interesting thing is the way the computer was interacted with, there's always a command. So it's like computer and then do something, in this case, Earl Grey hot. And, we kind of see some of this technology applied in the same way in the operating systems like Apple. And then, you can even think of like OK, glass, do this. So we kind of see some parallels there as well. And then Jarvis in Iron Man, Iron Man 2. So Tony Stark's had a pretty kick-ass AI system in his home. And I think, it also, extended to his car and, of course, the suit as well, which was pretty awesome. And then more recently, again, we've pushed the boundaries, in emotional intelligence. So in this case, Samantha. And I kind of wonder if it pays homage to SAM, or the Software Automated Mouth, in the name. So what about logic? Essentially, what I'm talking about here is AI. So what is the current state of the art in these affairs? If you guys probably recall Watson, obviously it's still awesome. So essentially, Watson is a QA system for information retrieval, and it had a large corpus of data, and it was all kept, primed and cached in memory. That's what made it fast. However, the actual interaction model was fairly narrow. So the way that you would query the system, it was kind of, it was very basic, or it is very basic. And that's how it's able to score and essentially rank things so quickly and well. On the other end of the spectrum, we see things like personal assistants, so Siri, Cortana, Google Now. And essentially we're dealing with input-output cycles, so you put a message in and it comes out. Obviously there's not nearly as much compute, so it's drawing a lot on APIs and other services. And in fact, it has no internal memory about who you are or what you like. It's fairly basic. And then there are other services coming online now. We're seeing like Magic App and Ethan, and Clara Labs is doing things around scheduling and automating that. And also, actually, the Siri guys the ex-Siri guys are now behind Viv, which is looking interesting, but it's still stealth. So that kind of brings us to Superscript. So Superscript is essentially, it's designed to solve conversational AI problems. And I looked at the Turing test, and more specifically, the Loebner Prize, which is essentially the oldest running implementation of the Turing test. And it happens every year. And so a lot of the examples I'll show kind of come from that as well. And by script, I mean it's essentially crafted dialogue. So it's not magic. It still involves a little bit of work, and it's a lot of fun to play with. And when I say conversation, I'm really talking about the most basic conversation. So like a one-on-one interactions where someone's trying to express an idea and come to some sort of shared understanding. There are other conversation models where there'll be a group situation where, there's that one awkward person that tries to add value. That's usually me. So Superscript is designed to work across mediums. So what I mean by that is you could have the conversation start in a socket or on the web, and then it could continue along and pick up SMS or what it be, through another API or email or whatever, and it's still, because it knows everyone uniquely, it's able to track and follow along. And really what this means more generally is it's API to API driven. So this allows you to tack on to the text-to-speech or the speech-to-text through other APIs. And I primarily did that deliberately so I didn't have to think about building the entire space all at once and kind of come up with something that people can play with now. And it's all written in Node. So here's a basic setup and get going. So essentially you require the library, and then essentially in those that little brackets there, which are omitted, is where you would pass in the model and some data that it might need. And then essentially the actual reply loop. So that would sit, there's one function, it's just called bot.reply. It takes in a user ID, which would be unique. So this would probably sit in your message loop, so as input comes in from whatever it happens to be, whether an API or some sort of socket or message, and then it would reply back and you just send that back to the user. It's fairly straightforward. It comes with two different authoring interfaces. So the first one is like just scripting and text, and I'll show essentially all these examples will be just that. But there's also a real-time interface for it's like a more interactive model, and it kind of speeds up the debugging cycle a little bit. This is essentially what it looks like. So the scripting model, you essentially write some text in documents, and then you compile them down using a compile command or bake them into a library. And then essentially it spits out a conversation model. In this case, I'm really referring to like a Mongo model. And then the real-time flow, it's all integrated, so there's no compile step. It feels a little bit more natural sometimes writing in the scripting interface and debugging things. However, they both work. So the first thing I realized is language is really hard. And it's not just language, but essentially, any sort of input validation is hard. And we see this in form validation on the web as well. So in this example, what's the color of the calendars? So here, what is wrong. It should be what is, or apostrophe at least. Color, we're using the Canadian or the Commonwealth word color. That can be a problem as well when you're trying to normalize data. And finally, calendars is spelled incorrectly altogether. So the system actually goes through and it's able to clean up, or what we call normalizing the text. It converts the Commonwealth words to American spelling, and it also fixes common typos, expands contractions, that kind of stuff. And then we keep two representations internally. So one is the clean version of the input stream, as well as a lemmatized version. So essentially where the verbs have been kind of boiled down to their root form, and then the inflections are taken off of words. So pluralization has been removed. And this kind of makes matching and input parsing a little bit easier. So in this example, this is from Laudner 2010, one of the screener questions. My name is Ed, what is your name? In this particular case, it's actually two pieces of input that come in at the same time, and this kind of tripped up a lot of the applicants that were competing at the time. So essentially what we have to do is we chunk this at a high level before it even hits the actual system, and we break it up to essentially two messages. And it's not necessarily chunked primarily on grammar, so on the period or the punctuation, but we'll also chunk on like a comma followed by like a WH word, so like a who, what, where, when, why. And then there's some other stuff in there that happens as well. Each message is then passed into the, each chunk is passed into the system, and essentially we parse them in series. And then in this case, so my name is Ed might find, we know it's a statement, and it might resolve to something like okay. And then the other piece, as we know that's a question, and it could match something like, my name is Rose. When everything is all said and done, the system comes back and returns essentially one sentence stream, and that's kind of how that works. So internally, like I said, we don't really deal primarily with just input streams. We deal with tokens, and we deal with essentially a fairly complicated message object. What that means is we pull up the POS, so the parts of speech. Is anyone familiar with what that is? Awesome. Okay. So parts of speech, essentially it's the nouns, the verbs, the adverbs, all of the different basic forms of the word. That's all been classified ahead of time, and it's stored internally. We also know if it's a question, and more specifically, what type of question. If it's a WH question, so like who, what, when, and why. If it's yes or no. If it's a tag question, or other sorts of things. We also do other. We pull out entities like dates, pull out names. We keep them all aside as well. And some of this we expose back to the scripting interface, and the rest of it we kind of keep internally, where you can plug away at it. You get access to all that inside plugins, which is kind of cool. So here's the top-down flow of how information kind of goes through the system. Like I mentioned before, we would do the high-level chunking, we then do normalization, and then we do some sort of topic acquisition, which we'll talk a little bit about in a minute. We find a reply, and then we filter some stuff out if it needs to be, and then we do some post-processing on that. And if there's anything left after all of that, it'll return it to the user. If there isn't anything left, if something happens to have been removed, it'll go back and keep looking for appropriate matches. So here's how the whole thing works. Here's an actual script, the most basic script that you would probably come across. So the plus notes that this is an input that we're looking for. In this case, it's hello world. And then there's two possible replies, denoted by the minus there. So welcome to Superscript, and welcome to the talk. The system is smart enough to know, just like any other sort of conversation, never repeat itself. So the first time this message comes in, it'll randomly pick one and return that to the user. And if they happen to say something again, the same hello world, it knows not to use the thing that it already said, and will say whatever's left. And like I said, if nothing is left, if everything's been filtered out, it'll look for something else to match. However, hello world is fairly strict and rigid, so you can add other things to make loosen up the syntax. So in this case, by adding braces, we can add optional words. So in this case, hello world will match, but also hello big world. I should also point out that grammar here is not important, so it doesn't have to match cases insensitive. If you want to do something like have optional words, those are in parentheses, and then you can have pipes between them. In this case, we don't know necessarily which one it matched, so the system saves that information and captures it back, and then you can use that later on as well. So hello big world or hello small world will work, but not just hello world. That will no longer work in this example. Like I mentioned, we capture that information where there's a choice or where there's input that we may want to do something interesting with. So this is from 2011 Loebner questions. What is a calendar? And this would reply, how would I know what a calendar is? In this case, we're using the parentheses again, followed by a asterisk, which is a wildcard. So it has to take at least one token, but it'll take as many as there happens to be. And then we return that back into that little CAP1 replacement. But what if we did know what a calendar was? What if the system was able to figure that out? This is kind of how that would work. So in this case, I changed the wildcard token to an asterisk 1. So it's looking for just one word, and it has to have at least one. And then we return that into this, what we call plugin. So this is an is-a function, and it would then return a calendar as a timetable, providing that's what it would do. And that's exactly what it does do. And here's how that looks on the actual is-a function. So everything is asynchronous, and because we're taking in one piece of information, one captured input, in this case calendar, that's term, the term that we're looking for. I've extended the scope of the plugin here to add the CNET, which is actually short for concept net. And this is essentially world data. The version 4, I think, has got, in this case, it's got 610,000 facts about the world. So essentially, this would give your bot maybe like grade 7 or grade 8 kind of level knowledge. So it knows quite a bit of stuff. We then do, essentially, we call this little function called make sentence, which just basically adds a period at the end and capitalizes the first letter to make it look nice. But you can also do other things. Because we're in node land here and we've got all the power of NPM, we can then call in other modules. So in this case, we're using a request to Google something. And this might be something like how Siri would essentially work. Has anyone actually used Hubot? This is GitHub's project. So, I mean, essentially, there's a lot of parallels here. There's some things that this does. It's maybe a little bit more involved and a little bit more natural in terms of how the input is parsed. But there's, like I said, if you're familiar with that, this should be fairly common. Parse body links here isn't defined, but essentially you don't want to return the entire Google results page. So I'm just imagining this would return something that would make sense to the user. And we also keep user state. So this is kind of where we differentiate a little bit. So like I mentioned before, the system knows who you are, and it's able to kind of keep track of that, providing that you pass in a token and identify the user. And then we also have a bunch of other databases internally. So we use a level graph under the hood, followed by sublevel, which is built on top of level DB. So we're talking about storing fact triples, which is subject, verb, object notation. In this case, user 1, my dog is named Roxy. That wouldn't collide with user 2 version of their dog, in this case Cody. And how that works is essentially we call a plugin for that as well. So we create user fact, Roxy is a dog and Cody is a dog. And then you can then recall that data later on. To actually fully bake this into the script, it would look maybe something like this. So here I'm using modified syntax. So noun 1 is something coming off the message object. In this case, it's the first noun in the input reply. And then we also look for the first entity, name 1. And of course, some people say named, or some people say called. Internally, we keep a database for every user, but we also keep one for the bot itself. So if you happen to write a bot that maybe takes on a human characteristics, it might have a favorite band or something like that, and you might want to bake that information in as well. On top of that, there's an entire shared world database that all the users can you can put data there as well that it's shared. So moving along, the next bit is topics. So essentially, conversations, they tend to flow in and out of different domains. What we do internally is every piece of input that's in the system is essentially attached to a topic, or it could be any one of them. So we use TF-IDF, or text frequency inverse document frequency, to do essentially a weighted score to figure out, based on the input and based on some keyword data, which topic is the most appropriate, and it kind of starts there, and then it'll cascade down with the best weighted results to find the right reply for the right piece of input coming in. We also continue on where we left off. So if someone had actually said something previously, it'll know to stay in that topic unless told otherwise, or unless it finds a better match somewhere else. On top of that, there's two special system topics, one for pre-processing, one for post-processing. So let's say at the end of the day, you've got nothing clever to say. You might want to have some sort of a greedier search, greedier match, I guess, in the post. And then likewise, if you're doing something where you're saving data to the system, you probably want that to happen. You don't want to have to rely on the input to actually match inside a topic. So you'd probably put that in a pre-topic, and then that'll hit. And of course, because it's performing some sort of function like saving information to the database or doing something clever, it probably doesn't return anything to the stream. So it'll obviously, or not, it'll just continue on. As well, we use plugins for filtering and conditionals. So we can really get kind of clever here by essentially taking a function that returns a truth value or some sort of truthy result. In this case, when asked, my name is Bob, if the system knows that it already has that name, it'll simply reply, I know you already told me your name, because the other result has been removed. However, if it didn't know the name, it would first save it. So it's calling a plugin to save the name there, as well as saying nice to meet you, and it returns the name. On top of that, we can do some other really interesting things around reasoning. So this kind of appeared around 2011 in the Lobner, as well as I think all of them since. So if John is taller than Mary, who is the shorter? And this could be who is the taller, and a couple other comparing terms. So in order to resolve this, we need to know what the opposites are. We need to know a little bit more about those adjectives. And we can simply bulk import all that data into that global database and then simply call upon it. And this is kind of how you would do that. So in this example, we keep a copy both ways. So if we're doing a lookup on the object, or if we're doing a lookup on the subject, it should find something. Once we have the data, the opposites kind of sorted out, we can then apply that to a script that might look like this, and this would save the fact. So if John is taller than Mary, we would create a user fact kind of like that. This reply is a little bit crazy. So if is optional, name 1 is the first name, and then I've got is or be more or less, because that happens to come up every once in a while. And then one of the adjectives in this case, taller or shorter or whatever, it knows. And then some people seem to get then and then mixed up, and I'm guilty of that as well. Name 2. So capture 1 is name 1. The optionals don't count. The adjectives would be capture 2. Then and then is actually capture 3, and we don't care for that. So we go to capture 4, which is the last name, and that generates that fact. Once we have the fact, now we can then look at the other side of the equation and figure out how to resolve it. So to do that, something like this might work. Here I'm not using a plus anymore, I'm using a question mark. So you can actually filter filter input on just questions as well. And there's a ton of other cool stuff you can do there as well. So here, who is taller, or who is shorter, or who is whatever, and then optionally name 1 or name 2 in the example. And in this case, we simply just punt on it and go to a plugin called Resolve Adjectives. And that's quite a bit of code, so I didn't bother including all of it. It's roughly 200 lines. But essentially what it does is it looks for the names in the message, but it also crawls back in previous messages because not all the information is in hand. However, we do have it, we just need to pull it out. Once we have some names, then we're able to look at the adjectives and compare them if they're the same, if they're different. If they don't match at all, like who is, I don't know, skinnier and taller, that just doesn't work, so we'd probably say something clever there. And then we logically compare them. And then there's some special cases around tallest, shortest. These are end cases, so we just want to typically grab one end or the other and then return that back. So looking forward, so that's essentially a fairly simple overview of what it does, and there's a lot of other cool stuff in there as well. But it doesn't do not everything yet. So I want to get into doing more advanced user modeling around essentially conversations that involve intent-based systems, so being able to have goals and have the system be able to figure out how to extract information that it may be motivated to find. And then kind of going a little bit further, looking at personality and mood. So essentially not every conversation is the same. Even if you say the same things to different people, it should be different. It should feel a little bit more natural. So my hope and intent is I can have some sort of system that it creates a unique experience with everyone that it engages with. And that involves a lot more context around the user model, knowing a bit about the sentiment and some of the tone and discourse and how the language has actually been parsed and passed into the system. And then as well, speaking back. So right now it simply replies when it's been spoken to. In previous versions I've had it, I prototyped it actually just saying things, whenever the conversation happens to run dry, or whether the topic has been changed, or if you've lost interest or walked away, it can then kind of re-engage with the user. And then on top of that, I guess looking at more group chat situations. So right now it's really great on direct one-on-one engagements. But let's say for interacting with Slack in a group chat situation, the bot would take on different characteristics. So it doesn't necessarily need to reply to everything. It probably wants to have some sort of velocity and know when it's being spoken to, knowing when it can add value, knowing when to shut up as well. So that's kind of where it's at, and that's all I've got. I think I probably ran through that really quick to make up time.